Hello friends, now we are going to discuss another algorithm technique called space-time and trade-off. Okay, like other algorithm technique you have studied like divide and conquer, decrease and conquer, greedy method. Like similarly, we have a space-time trade-off. Now, why it is called space-time trade-off? Remember that by providing extra space, our tendency is to decrease the time complexity. Okay, decrease the complexity. So these extra space maybe we are using for the input enhancements or pre-structuring. But remember, when you are going to use any other data structures to pre-structured, right, then it will take extra bytes of space, right. So we are providing extra space in order to decrease the complexity of the problems or decreasing the time complexity of completing the task. Here in this particular topic, we are having two algorithms, sorting by counting and input enhancements in string matching horsepull algorithms. So one by one you are going to discuss sorting by counting, how you are going to count the given number based on counting. We can sort the number by using bubble sort, selection sort, insertion sort. I have studied quick sort, merge sort, right? But we can sort the element based on counting also. We can count or we can sort the elements, right? And there is another topic called string matching, right? Horsepull algorithms. If you have studied that linear pattern matching algorithms, as we have done with, right? KMP algorithm, right? Boyer-Murray algorithms. Similarly, we have horsepull algorithms. So how you are going to perform the task in horsepull algorithms? How exactly are we going to find out the pattern in the given text, right? That you are going to learn in the second chapter under space, time and trade-off. Let us see that about input enhancements, right? It is pre-process the problem's input in whole or part and store additional informations obtained to accelerate the problem solving afterward. It means maybe we are going to perform the task by using some arrays, some different structures, such a way that we can perform the task faster. As we are having example, sorting by counting, pattern matching using horsepull algorithms, Boyer-Murray algorithms for string matching. These Boyer-Murray algorithms, we can go with that and see how it is different from horsepull. But as per your syllabus, we have horsepull algorithms. Likely, input enhancements, we have pre-structuring. Use extra space to facilitate faster and more flexible access to the data. Based on this, we are having the concept and we can use this concept under space-time trade-off called hashing, indexing with bit trees. While you are doing hashing, there also you are going to perform the task like we will be having some bigger keys, how you are going to convert those bigger keys in a smaller set of hash values, right? So that is basically we are converting larger integer size into the smaller size. Right? So of course we are going to find out the remainder method applying number divided by mod, number mod table size, but our tendency is again to convert larger values into the smaller values. Of course, this is not there in your syllabus. Right. First algorithm, what you are going to learn from space, time and trade-off is sorting by counting. Count for each element of a list to be sorted. The total number of elements are smaller than an element and record the results in tabular form. We'll see with an example. These numbers indicates the position of the elements in the sorted list. The list is sorted by simply copying its element to their appropriate position in a new sorted list called comparison counting. It means sorting by counting can be asked like a comparison counting. Now to see that example, With example, we can learn and we can understand in better way. So, if you are saying that we are going to count different values, whether values are smaller or larger, right? It means we are going to compare, and comparing and counting that particular elements are either greater or lesser. It means at the beginning we should have the count values of all the elements. Let us see that how exactly it will perform. Say, as for example, we are having 18, 10, 3, 5, 20, 7, right? No, this is not sorted. We have to sort it in ascending order. What you are supposed to do it? First, you are going to initialize the count for all the elements. So, what will be the array index here? 0, 1, 2, 3, 4, 5. So, how many number of elements? Total number of element is n is equal to 6. In n is equal to 6, index start from 0, last value is at the place of 5. Now, let us see. Initially, we are going to initialize the count values for all these elements from I is equal to 0 to I less than n as a 0. Means we have not counted anything. So, let us see. At the beginning, we have count values for all the elements 0. Right? So, we have count of I is equal to 0. Now, first element, you go and compare with all the elements and see that first element is bigger than how many number of elements. Right? So, let us see that in first iterations, right, when you are writing count, in first iterations, we are going to perform the task. Say it is first iteration. 18 and 10. We are going to compare, right? 18 is larger, so what happened here? This count value becomes 1. This will be remain 0 because 18 is greater than 10, right? So this count becomes 1. 10 is remain 0. Now 18 and 3. Now 3 is lesser than 18. So, still 18 we can say that 18 is bigger than 3. So, count values of 0 increases. So, let us see that I am going to complete the task one iterations, thereafter we will understand. So, first it was 0, then what happened? We compare 18 and 10 becomes 1, this is remain 0. 18 and 3 when you are going to compare, again 18 is greater, it becomes 2, this is again 0. 18 and 5, still 18 is greater, so this becomes 3, these all are 0. 18 and 4, just compare 18 and 20. So 18 is lesser, 20 is greater, so this value becomes 1, right, and this is remain 3. Similarly, we are going to compare 18 and 7. 18 is greater, hence this becomes 4. This is 0, 0, 0, 1, 0. So, after these 1 iterations completed, we got the values of 18 is greater than how many number of elements. And how many elements are greater than 18? That is only one element. So, this is the first iteration. Similarly, what will happen in the second iterations? Look, in second iterations, we are going to increase the pointer of I. So, initially, we have started I from here, j started from here. It means what? I start from 0 to n minus 1. J started from I plus 1. So, 0 plus 1 is 1. So, j positions will be always 1 ahead than I positions when you are writing the algorithm, because we are not going to compare the same element with same element. You are not going to compare with same element, right? You should have a different element to compare. So, here 1 is I, second is I, j means what? 1 ahead of I positions. Second iterations, we can do little faster. Look, 10 is greater than 3. Yes. So now we'll forget about this. This is stopped there only. Now we are going to perform with this. I is equal to 1. 10 and 3. Yes, it is greater than 3. So 3 position is 0 only. 10 and 5. Yes, 10 is greater. It becomes 2. Right? 5 position is 0 only. 10 and 20. Yes, 10 is lesser. 20 is greater. So position of 1 is increases to 2. Right? Then 10 and 7. Of course, position of 10 increases. It is becomes 3 and 7 is 0. Look. Second iterations we got to know that, okay, I is equal to 1, count value is 3. It means 10 is greater than 3 elements, 3, 5 and 7. Similarly, third iterations what will happen, friend? These 2 is done. Now we are going to start with this position. Okay. So in this case, we can see 3 you are going to compare with 5. 3 is lesser, no problem. 5 is greater, yes. So 5 position is 1. 3 is remain 0. It is remain 0. Right? 3 and 20. 20 is greater. 3 is smaller. So now count value of 20 is 3 now. 2 plus 1 becomes 3. 3 and 7. Count value of 7 becomes 1. It means now in third iterations we got to know that count value of 3 is 0. Similarly, now we are going to deal with the next position 5. 5 and 20. Since 5 is smaller, 5 count value will remain same, 20 will be increased. Count values for 20 is 3, 3 plus 1 becomes 4. 5 and 7, 5 count values will remain same, 7 is greater than 5, so count value of 7 becomes 2. Remember, we are just increasing the count values when value is larger or greater. Till here is done. Now next is I is 4th positions and 7. 20 and 7 you are going to compare. Since 20 is greater than 7, count value of 20 becomes 5 and 7 is remain 2. Now we can conclude these count values. All together we can conclude these count values. Right? So let us see how it looks like. Here you have 0 index 1, 2, 3, 4, 5. Okay. And we can see that count value of 0 is 4. So here we have count value is 4. Right. Similarly, count value of 1 is 3, 0, 1, 3, 0, 1, 3, 0, 1. Then we have 5, 2, 5, 2. Look friend, this 4, 3, 0, 1, 5, 2 is says that this particular value is bigger than how many different elements, right? So, one by one, we will take that elements which is stored in A of 0 and we are going to put it at the place of 4. How we will do it? Say if name of the array would have A, if name of the array is A, right, then we are going to place it here A of count values and these elements are going to place. So, let us see that. We are going to write it here. Yeah. If array name is A, then you are going to write A of count of I is equal to A of I. Let us see that. Try to understand it. A of I is nothing but we are going to think of these values. A of 0. A of 0 is, what is the value of A of 0 in previous iterations? 18, 10, 3. I have to rewrite it. This value is 18, 3, 10, 5, 27. Probably this value was there. 527. Now let us see that. These all are the values. This is A of I. A of I, I'm going to place it. Where are you going to place it? A of count of I, count of 0. What is the count of 0? 4. A of 4 is equal to A of I. What is the value of A of I? 18. So A of 4 is equal to 18. Similarly, go to the next value. I becomes 1. I becomes 1. Count of 1 is 3. A of 3 is equal to, what is the value of A of 3? Is remain 3. A of 3 is equal to 3. Similarly, I increases 2. A of 2 is 0. A of 0 is equal to A of 2 is 10. These elements you take it and put it in these count values. 4, 3, 0. Right? Similarly, we have 1. A of 1 is equal to 5. A of 5 is equal to 20. And A of 2 is equal to 7. So look, based on the count values, we assign these values. And of course, when you are talking about return A or write array index A, then we will fill like that. This is your output. A of 0, 1, 2, 3, 4, 5. A of 0. See that A of 0 index, what values we are having is just 18, 10, 3. Sorry. It is 18, 10, 3. 18, 10, 3. Okay. So this is basically 10 and this is 3. Sorry. A of 0 is 3. A of 1 is 5. A of 2 is 7. A of 3 is 10. A of 4 is 18. And A of 5 is 20. We can see that this element is already in sorted order. These elements are in sorted order. So this is basically concepts called sorting by counting. So let us see that how you are going to write the algorithms. We are going to write comparison counting. What is the input? Input is arrays from 0 to n minus 1 and output is sorted arrays from 0 to n minus 1 index in non-decreasing order. First, what we did it? Firstly, we have initialized the count values as 0. So we are writing I is equal to 0, I less than n minus 1. Count is equal to 0. For each and every element, count is 0. Next, I is equal to 0 to n minus 2. J is equal to I plus 1. Next element to n minus 1. If A of I is lesser than A of J, which is greater? A of I is lesser than A of J means A of J is greater. So count of J will increase. Count of J is equal to count of J plus 1. Else, if this statement is wrong, it means what will come in else part and count of I is greater. So count of I is equal to count of I plus 1. Once we complete this, what we did? After counting of iterations, we did assignment of actual array element based on the count of I index. So count of I becomes the index of sorted elements. So here we are writing I is equal to 0 to n minus 1. Do S of count of I is equal to A of I. I return S as a sorted element. I repeat, count of I is going to be index of sorted elements. Summary of this algorithm is, it's frequently used as a subroutine in other sorting algorithms such as radix sort. And it's also used in concept of hashing, right? How to perform the task based on sorting by counting. Similarly, we have one algorithm called frequency distributions counting. So please go through that frequency distributions counting. Thank you very much for this.